So what I want to talk about today is compression bits. This video is mainly for new CNC users, people who are new to CNC and are just learning at what all these bits are. So compression bits are becoming more and more popular. So I just want to go over what they're used for and why. So there's 3 bits here. In order to learn what a compression bit does, you really need to know what spiral bits do. So we have an upcut and a downcut. Also, this video we'll be talking about wood. Compression bits are used in wood. That's the main function of a compression bit. You normally don't cut different materials. You're not going to use a compression bit in aluminum, for example. So it's basically made on wood. We'll get to that. So in order to know what a compression bit does, you need to know what an upcut and a downcut bit do. So for this video also we'll be using 2 flute spiral bits. So this is a 2 flute upcut, 2 flute downcut, 2 flute compression. They are available in different flutes. You can get a single flute, you can get a 3 flute, but just to keep it consistent, we'll be using 2 flutes, most common. So upcut. So 2 flute upcut spiral. The advantages of using an upcut spiral are it's great for evacuating the chips. So as this bit is cutting, it's pushing the chips up out of the way, away from your material. This is great for reducing the heat buildup in your bit. It gives you a little bit more speed because you're not recutting the chips of the wood. The downside for an upcut is that it tends to tear away the top edge of your wood. Basically, the way a spiral bit works, it's a shearing motion. So as this flute is cutting through the material, it's kind of like a pair of scissors where it's chopping. It's a shearing motion. So if you have fibers of the wood, as that bit is coming through, it's applying a lot of pressure to the top side of this bit. It's cutting in an upward motion. So what that tends to do is you get tear out in the top of your material. So if you're cutting plywood, a lot of people will have tear out issues where this top veneer of the plywood is going to be chipped out because as that bit's cutting, it's pushing up. There's not a lot of plywood, there's not a lot of thickness on that ply, and it's going to chip it out. The other hand, on the bottom of your surface, the bottom of your plywood, so as this bit is cutting, it's shearing in an upward motion. That bottom ply is supported by all this other material to get a nice crisp edge. So that's upcut. Let's talk about downcut. Basically, it's the exact opposite. So with the downcut bit, the design of the flute is going to be pushing chips down. Now, this is great for a nice top finish. So as you can see, if this is our material, it's going to be cutting down. Our top ply is supported by everything underneath. You'll get a nice crisp edge. But what it does is it's forcing the chips down. So the only thing that you need to think about when you're using a downcut bit is that all the material that you're cutting is now being pushed back into your hole. So this has a couple effects on the bit. You're recutting the chips, but you're also, the force of the cutting and the fact that the chips are still in the hole is going to push your bit upwards. So the force applied, instead of pushing your material down because it's supported by your wasteboard, it's going to push your downcut bit up. So sometimes you'll see people use a downcut bit and they'll have a small lip around the outside of their pocket. They'll have a small lip around the edge of their letters if they're cutting letters. That is because of the downcut bit, because of the forces applied. If you're cutting a pocket, your first plunge, you've got full contact on all sides of your bit, plus the pressure of the chips being forced down, pushing your bit up. You'll have a small lip on that first plunge of a pocket. Once you step over one step, you're allowing those chips to go in the already cleared area, which releases the pressure on the bit, lets your bit sink down in your pocket a little bit. So you're gonna get that little tiny edge. So now that we know what an up and a downcut bit does, let's talk about compression. So compression combines the best of both. Normal compression bit will have an upcut section at the bottom and the rest will be a downcut. Typically, the upcut section will be roughly the diameter tip. So this is a 1/4 inch compression. This upcut flute length is about a 1/4 inch. It could be a little bit less, could be a little bit more. That's just a rough ballpark. Now, what compression bits are designed to do is to cut the bottom and the top of your material at the same time. So if you're cutting a piece of plywood, ideally the way this bit was designed to cut is you want to cut the bottom and the top at the same time. That way you're having a nice flat edge. The reason they're called compression bits is because this bottom section is sending your chips up, the top section is sending your chips down. It's compressing the bits, it's compressing your material, hence compression bit. So ideally, on a compression bit, you want to cut the top and bottom of your material at the same time to take advantage of what a compression bit is designed to do. That's not always going to be possible. So keep this in mind. You want to be cutting past the bottom. So this bottom is an upcut. You want to at least cut past that. I normally go another 50%. So if this is a 1/4 inch bit, I'll go up another 50% of that length to take advantage of the compression. So on a compression bit, ideally you want to cut both surfaces at the same time. You want to be able to cut the top and bottom at the same time. That's not always possible with the smaller hobby level machines. So just keep this part in mind. You want to cut past this bottom section of the bit. Your depth of cut should be past that, and then I normally go at least another 50%, 25 to 50% above that, because you want to take advantage of this downcut section. Because if you're only using this very tip of this bit, you might as well just use a downcut. That's all you're using. Compression bits typically are 25 to 50% more money than a regular 2-flute up or down cut bit. That's because there's more engineering involved when they design them. There's more cut time involved with all the different angles. So if you're only taking advantage of the bottom of that bit, you might as well just step to an up or down cut. Save the compression bit for when it's needed. The main reason compression bits, like I said before, they're for the bottom and top of the material. The majority of the time, that's going to be plywood, it's going to be melamine, anything that's got a laminated surface, top and bottom, is when you really want to use a compression bit. Let's talk about using a compression bit. So on my CNC, when I cut plywood, I use a compression bit. That's what they're made for, that's what they do, that's what I use. The wasteboard of your CNC will offer a certain amount of support for that bottom grain. If all you have is a downcut bit, that's perfectly fine. You'll get minimal tear out on plywood. You will get some, depending on the grade of the plywood that you're cutting, you'll get more or less. If you're using very cheap plywood, it might not be cheap as in the cost nowadays at Home Depot, places like that. But if you're using a very thin top veneer, top and bottom of plywood, the chances of getting bottom tear out with a downcut is pretty good. If you use a compression bit, you shouldn't get any. Now, cutting hardwood. So let's talk about hardwood. So if you're familiar with woodworking, then you'll know that if you're using a handheld router or a router table, you're doing a flush cut on a nice piece of hardwood, you want to use a compression bit. The compression bit will shear top and bottom layer, give you a nice clean edge. If you use a downcut bit on a router table, you'll probably get a little bit of blowout on the bottom because this edge is not supported. Same with an upcut bit, you'll get it on the top. So that being said, if you're using compression bit in hardwood on a CNC table, that bottom is now supported. The bottom is being supported by your wasteboard. Hardwood has a nice hard grain, most of them. This little bit of support is all you need to eliminate the majority of the tear out you're gonna get. So when I'm cutting hardwood, I will use a downcut bit versus a compression bit. Just because a compression bit, where it does work in certain applications, the added cost of using a compression bit versus a downcut bit, for me, I'd rather use a downcut bit. I've been cutting hardwood for 15 years on a CNC. I've never had a project go wrong with a downcut bit in hardwood. So another thing that I see people doing is using a compression bit to cut a pocket in a nice piece of hardwood. Does it work? Yes, it does. Is it the right application for a compression bit? No, it's not. Compression bit is made to cut top and bottom surface. You get a downcut and an upcut, you get a nice flat surface. If you're using it to cut a pocket, you're missing the point of a compression bit. If that's all you have and that's what you're doing, fine. But that is the wrong application for a compression bit. The bottom of a compression bit is the same as the bottom of an upcut bit. It's the same, there's no difference. So you're not gonna get a different finish on the bottom of your pocket by using a compression bit. You're gonna get your nice top finish because you've got a downcut, but that bottom section of your bit is no different than an upcut or a downcut. You should get the same finish. If you have a properly set up machine, your pocket's gonna be flat. Doesn't mean if you're using an upcut, downcut, or a compression bit. So you can use a compression bit if that's all you have. Just keep in mind, you're using a $40, $50 bit compared to a $20, $25 bit. I personally would rather use a cheaper bit and keep the life in my compression bit for when I need it. Okay, let's talk about 1/8 inch compression bits. Now, I've been doing this for about 15, 20 years. When I first started, these weren't around. If they were, I wasn't aware of them. So this is something new, I think, that came out in the last few years with the explosion of the entry-level, hobby-level machines. People wanted a little bit more detail than you could get with a 1/4 inch bit. So these came out, and I could be wrong. So 1/8 inch bit, you've got some limitations. You're not gonna run an 1/8 inch compression bit at the same speeds that you're gonna run a 1/4 inch bit. It just doesn't work that way. That being said, I use a lot of 1/8 inch bits in 1/2 inch Baltic birch. Now, the way that I always learned is that a compression bit is meant to cut the top and the bottom of the wood at the same time. Is that reasonable to expect from an 1/8 inch bit, 1/2 inch material, and a hobby level machine? Not really. So the bits that I have, these are bits, this is a bit I got off Amazon. This is a compression bit that I had made. These have been changed just a little bit. A typical spiral has, it's a standard angle. I'm not sure, I'm not an engineer. You can see these two angles are pretty similar. This compression bit has a steeper angle, which allows the chip to evacuate a little bit quicker, which will allow you to do a deeper cut a little bit faster speed. Let's take a look at this compression bit. So I run a lot of 1/2 inch Baltic birch at home on my hobby level machine. Is it reasonable to think that I can run this 1/8 inch bit through this 1/2 inch material at the same speed I can run a 1/4 inch bit? Not really. In my experience, I've found that if I run this bit in 2 passes, I get a better result than trying to do it in 1 pass. Now, I'm going past the upcut portion of the bit, and I'm into the downcut portion. So I'm taking advantage of both parts of the compression bit. Is this ideal? No. Does it work? Yes, it does. So what I'm gonna do now is I'm gonna do a couple tests on the machine. I'm gonna use an up, a down, and a compression bit, show you the difference of what each bit can do. We'll take a quick look, and then you can see for yourself and judge. there's our 3 pieces. Got the top, a little bit of tear out against the grain. With the grain, not so much. On the bottom, like you'd expect, all 4 edges are nice and crisp. On the down, top edges all nice and clean. Flip it over though, quite a bit of fuzzy on the bottom. It's basically just folded over the fibers against the grain. Didn't cut it. The edges are nice and crisp. And the compression bit, all 4 of the top edges, nice and clean. Bottom, and if you really wanted to get picky, there's a little bit of fuzz right there, but nothing a little bit of sandpaper couldn't do. But compared to these, you know, a lot less work to clean this one up than these 3. So there's our 3 pieces. You get the idea what a compression bit is for. You know, hopefully you got something from this video and you understand why we use a compression bit, what they're made for. Like I said, they are more money, so just keep that in mind when you just start throwing a compression bit and just start cutting away at material. I'm going to put a video of that compression bit running 3/4 inch plywood at I believe it was 300 inches a minute. So it's a little noisy, but it's pretty fun to watch. All right, see you guys later. So I have a link down below for the compression bits that I use for this. Any questions, let me know. Thanks a lot. So I figured I would do a comparison with the 1/8 inch bit. Might as well throw that in there, try it out. So here we go. So if you can see that, perfect little edge. This is the 1/8 inch bit. I use this bit quite a bit. It's really done quite well for me, so I'm pretty happy with this little bit. So that's it. And if you've made it around to the end, thank you very much. And as a little bonus, I thought I'd share this little fact with you. Compression bits. So not many people know this, but they were actually made, the first ones ever made were by the Spanish in 1742. So that's pretty neat. They were designed to help fight the plague. So yeah, that's not actually true, but don't tell anybody that. Yeah. Later.